All right, another short video here. We want to go about putting a list in your calculator, finding the mean and variance and standard deviation of that data set. So I'm going to do it by hand, and then I'm going to show you how much easier it is to do on the calculator. So I have a very small data set here of 5 individual data points. We look at that as x sub 1, x sub 2, x sub 3, x sub 4, x sub 5. These are the 5 values. We look at the formula for a mean, the sample mean, x bar. We say x bar here is the sample mean. We add up all the values. This means you take the sum from 1 to 5 of this expression. So you plug in I equals 1, x sub 1, which is 7. And then you add the next I when I is 2, x sub 2, 13, and so on till you get to the number up here. Whatever n is will be the number up here. So we're going to have the sum of n values, in this case 5 values, and we divide by the number of observations. That's just an average, right? The average value. In this case, nicely, when we add up the 5 values and divide by 5, we get a whole number of 16. Obviously, that's not always going to be so clean. But I made it this way for illustrative purposes. The variance and standard deviation are related in this way. The standard deviation is the square root of the variance. The variance is the standard deviation squared. So we have a formula for variance here. And look, it's more complicated than the formula for the mean. And this is why you need a good calculator with a statistical package, so you don't have to go through this every time you're asked to find a standard deviation, right? But it's good to see where it comes from. So we're going to go through this example to show it. So this is the formula. Here we take the sum of the difference between each value and the mean that we just found. So we take the difference between the first value and the mean, square it. That's what this is. First value is 7. We take the difference between the first value and the mean, and we square it. We take the second value, x sub 2, subtract the mean, and square it. We take the third term, the fourth term, and the fifth term. And in this formula, we divide by n minus 1, just because. So we get a 4 there. So the difference here is negative 9. The reason we square it is so we get a positive value each time. If we did not square the value, well, the half the values are going to be more than the mean, half the values are going to be less than the mean, or the amount greater than the mean will always equal 0, right? So that's why we square the values so that we get an idea of how spread out the data is. This is a very small data set, but again, just for illustrative purposes. So we add those up. Negative 9 squared is 81. Negative 3 squared is 9. 0. 5 squared is 25. 7 squared is 49. We add that up. Again, nicely here, we get a whole number of 41. So 41 is the variance for this small data set. The square root of that number gives us the standard deviation. The standard deviation here is 6.4. So this is a measure of how spread out the data is. Here we see we have a minimum value of 7, a maximum value of 23. There's only 5 values. Standard deviation, the larger the standard deviation, the more spread out the data is going to be. Smaller the standard deviation, the more packed together the data is going to be. So let's look at how to do this on the calculator so that you never have to do it by hand again. Okay, so here we go. My handy dandy calculator, emulator. So we can go through the whole process here since this is a small data set. So we want to input the list. So let's go to the stat package, edit, hit enter, And when you want to get rid of a list, you use the arrow to go up to the top, hit clear, go back down, and that list of values will be gone. Now you can also name these lists if you like. You can use the second function or the letter function and name these lists. Z2 is what I named. If you want the letters, you go to alpha. If you want just the numbers, you leave it as it is. So 2Z2, if I hit enter, whoops, what the hell's going on here? All right, maybe we won't answer, or maybe we won't label this. I think maybe you got to put it in quotes or something. It's not really important. Let's not waste time on it. We'll leave it as L1. That'll make it even easier. Okay, so let's put the data in 7. Maybe I'll do another video once I figure out how to name them. I used to be able to do it, but I guess obviously I forgot. I think you might have to put it in quotes or something, but no big deal. 16, 21, 23. 16, 21, 23. All right, so there's our very small data set. We want to find the mean and standard deviation, so we go back to the stat menu. We move over to calculate. This is a one variable data set. There's only one thing being measured. Sometimes we have 2 variable sets, but we're dealing with 1 variable sets here. We put it in. We put the list that has the data in. We don't care about this next item, but we go to calculate. We hit enter, and we get everything we want here. We get the mean is 16, like we said, and we're going to use this value here. This value and this value will be close. We want S for sample standard deviation. This is an approximation of the population standard deviation. When we're asked for standard deviation, use this one specifically, okay? SX for sample standard deviation, and you can see it matches our values. The mean was 16, the standard deviation was 6.4. All right, so that's what we're looking at. That's how you input data and use the one variable stats. See you next time.